I developed this webpage using Kiro's spec mode. After entering the requirements, it started working. In about 10 hours, I managed to build an interface that worked mostly as intended. I added a hook supposed to enforce my preferred coding style, but it rarely executed. What I built is the AOBPlayground, a demo that shows how AOB works. AOB is an advanced blockchain technology where each blockchain represents a single banknote. Each user owns some blockchains, and an owner can transfer a blockchain banknote to another user by adding a block. In this way, payments are made simple. This forms an ideal type of cryptocurrency. On the left is the control panel. Here you can define blockchain banknotes by editing the mapping between each blockchain's serial number and its face value. Once that's done, you verify and generate the hash value of this definition. This hash will be embedded in the genesis block of every blockchain. You can verify the hash value directly here, or copy the verification code into the console. See, the verification passes. Now let's run the demo. Across different tabs, you can see detailed information about nodes, users, and blockchains. In the initial state, each blockchain has two blocks, the genesis block, which defines the banknote, and a second block that assigns the banknote to a user. The current owner can then add a block to transfer it to another user. Now let the owner send the blockchain we just selected. You can watch the broadcast message propagate through the network. After receiving the new block, each node waits for a period before trusting. This is to prevent double spending attacks. You'll see that the nodes which trust the new block turn blue again. 3 nodes remain untrusted. These belong to the recipient, who needs to wait longer before confirming. This waiting time ensures the new block has reached the entire network, so that even if a conflicting fork appears later, every node can determine which block came first and ignore the later one. Looking at this blockchain, you'll notice one more block has been added. That's the payment block we just broadcast. Now let's test a double spending attack. When a forked block is released, it fails to spread and instead triggers an alarm. Each node that receives the forked block broadcasts an alarm. Any node that receives the alarm first blacklists the attacker, then checks the earlier block status. If it wasn't trusted yet, it will never trust that blockchain again. Since only one person can add blocks to a given blockchain, the presence of a fork is undeniable proof of an attack. This is a key difference from public blockchains. That's the AOB Playground. Thanks for watching.